nitrate sample by visible spectrophotometry is a 70-point lab notebook experiment. As you looked through your procedure and went through and calculated the data, you probably noticed that on page 252 and 253, there was information provided to you to give you sample sets of information. This set of sample information is very useful in being able to understand what to do with your own data that you collected. And as I go through this video, I'm going to explain to you where all this comes into play. For example, you're going to notice that in table number 2, you have information about copper sulfate in 5 waters, and it gives you gram amounts. Okay, so these data points in grams amounts are similar to what you collected. Okay, so if I slide over to your data table, this is data sheet number 1, and you're going to notice that in blue for part 1, we have our data that we collected for the cobalt chloride with hydrated. It had 6 waters that was collected when you did the lab. You then use that information to get the absorbance. Okay, so we have this column and we have that column. In a similar fashion, that is what's given to us here along with the absorbance information. Now, what you don't have and you need to find is this column right here. Why do you need that? Because that is going to give you your concentration values that you're going to plot along the x-axis. And then along the y-axis, this is your absorbance, that's going to be plotted along the y-axis when you make your graphs. Okay? So as you slide down with me, how do we get this information for this column? Well, the information provided with equation 2, as well as this mass fraction information, is how you do that, okay? So what you're going to find is we have to follow this little pattern right here in order to get this little number that's going to be your multiplier number. Now, in this example problem, they're doing it for copper sulfate with 5 waters. We have to do it for the cobalt chloride, okay? And then once you have that, you're going to come back up here and you're going to apply equation number 2, okay? All right, so I don't want to get too far ahead. All right, so let's slide over, okay? And as I slide over, let me show you one more just piece of information. All right, I'll circle this in red. On page 257, this is where your list of calculations are, okay, for part 1 and for part 2. Each of these tasks, 1 through 11, you're going to check off as you go along, okay? So our very first thing that we want to make sure that we do, all right, is calculate the grams of cobalt in each cup using the modifications of equation 2. And then you're going to record these in data sheet number 2. All right, so we're right here, all right, and we're going to slide over here. All right, so here's data sheet number 1. Okay, so here are cups A through E. All right, and we're going to slide. Actually, you know what? Wait, this is what we have to transfer over, actually. Okay, so you need to have room to do your calculations. All right, so what I'd like you to do at this point is take these 2 columns that are in blue. I'm going to circle the little arrows that are the green arrows. You're going to take those 2 sets of data and you're going to put them in data sheet number 2. Okay, so right here. Okay, so there's your absorbance that you are going to place this information right here. So there's your absorbance data. Okay, now we have to figure out the cobalt column. The first task, so I'll label this as number 1, is you have to do the mass fraction of cobalt in cobalt chloride. Okay, now the process for doing this, you more than likely learn to do it in class, but you're going to take each of your elements and you have to add up the periodic table weights. Okay, so we have cobalt, which has a mass of 58.9. We have chlorine, and we have 2 of them, each at a mass of 35.4. And we have our water molecule. I'm not going to separate them out individually, but we have 6 water molecules, and water has a mass of 18. Okay, so that gives me 58.9, 70.8, and 108. All right, so I'm going to total them to get a sum, and that gives me approximately 237 grams per mole. Okay, and again, I may have rounded a little bit. Okay, so how do we get the mass fraction of the cobalt? All right, well, what we have to do is we have to take our cobalt and we have to divide it by the total. So 58.9 for our cobalt divided by 237, okay, is going to equal, and I'm rounding to 3 decimal points, 0.248. Okay, now that actually becomes what I'm going to call my multiplier. Okay, now the next thing, this is where you need your mass from the previous data table. Okay, so let me just slide back for you right here. Okay, do you see these masses? Okay, you're going to take each of those masses and you're going to multiply them by that multiplier. Okay, all right, so my first mass, and this is going to give me, I'm going to put number 2 for your second step. This is going to give you your concentration information. Okay, so the first one is 0.2835 grams, and then you're going to multiply by that multiplier of 0.248. And when you do that, you're going to get 0.0703. And again, I'm taking it to 3 sig figs. All right, so this is your multiplier that goes here. Now, this number, the 0.703, okay, that is going to come up and it goes right here. So 0.0703. Okay, now you're going to go through and you're going to do the next mass. So whatever your next mass is, and you're going to multiply by that multiplier again, and so on. You're going to do it for all 5 of your samples, okay? Make sure that you show all of your work, okay? So show your work on your piece of paper in your lab notebook. Once you have all of them, you're going to fill them in. Okay, as I'm filling them in and explaining the process to you, you now have enough information to generate your graph, okay? Because again, just taking you back, if you go back over to the instruction sheet on page 252 for part 1, you now have, and I'll change colors, we'll make it purple. You now have the information for your data to put on the x-axis and the information to put on the y-axis. All right, so this is your concentration. Okay, so this is the concentration that goes on the x, and this is the absorbance that goes on the Y for your graph. Okay, so plot these. Okay, now remember, as you're plotting them, you have to do not only the graph by hand, but you also have to do it by Excel. Okay, so you have to do it by both. Now, what is that going to look like? Okay, well, giving you the reference so that you, again, remember where this is coming from. This is what your graph should look like using the example in the lab itself on page 253. Now, from this, once you have it graphed, and I'm going to show you that in a minute, once you have this, then you can figure out the slope from it. The slope information is on the previous page down here at equation number 3. Okay, so if you look at the bottom of page 252, all right, it gives you information on how to find that. So we're going to fast forward in my work, and I'm going to show you my graph. Okay, now keep in mind that as I plotted this, I did do it on separate graph paper because I don't have a lab notebook. But as a reminder, students do need to do it in your lab notebook. Okay, so make sure that you space things out appropriately. You're plotting absorbance versus concentration. It should look very similar to what you have here. You should have a title. You should have 5 data points. You should draw your best fit line using a ruler. It should go through the origin. Okay, now let's fast forward to the slope. In order to figure out the slope, as I showed you at the bottom of page 252, you are taking an absorbance value and dividing it by one of your concentration values. Okay, so that's explained, and right here is where I selected my point. Okay, so my absorbance was 0.6, my concentration was 0.175, and when I divided them out, I got 3.42. Now, where does that go? All right, so here we are back at our data table where we were before. Okay, let me switch over to, we'll go to pink, all right? So at this point, 3.42, which is my slope, is equal to epsilon. Okay, so again, I got that from 0.6 divided by the 0.175. Notice I'm showing my work. Okay, 3.42 happens to be my slope. Okay, and that is equal to epsilon. Okay, so we have basically done a few steps all at once. Okay, so in terms of the graph, that was the third thing that I did. And then from the graph, step 4, I was able to figure out my slope. Slope. Okay, now, there is a very good chance that your slope could be a little different between your hand-drawn graph and your Excel graph. So, that I'm going to leave up to you, all right? I happen to be very good at drawing graphs by hand. So, I was very confident in the slope that I got from it. Okay, but rely on Excel. All right, now, that takes care of that page, 263. Okay, so you're ready to move on to part 2. Now, this is the step that you did 100% on your own unless you ran into a problem like in one of my lab classes. All right, again, you're getting out of the 4 columns, you're getting the first 2 columns from your data. Okay, so what you're seeing in blue, I pulled from right here. Okay, it's the same information. Okay, all right, so I took that information and I moved it over to part 2. Now, essentially, you're figuring out the copper once again. Okay, so the cobalt concentration, You're going to get by doing calculations using Beer's law. Where is this in the experiment? So if you go over to page 253, all right, our information about this is right here. Okay, so our goal is to find epsilon, which we did from the slope, okay? And you're going to plug that in to allow you to figure out your grams of copper. And then from that, you can figure out the mass percent. Okay, so essentially what I'm going to show you how to do is to utilize equations 5 and 6 to fill in those columns which you need. All right, so back over at your data table. All right, how do we do this? All right, so let's slide down here. All right, we're going to take our equation. C equals concentration equals absorbance times epsilon. And we're going to rearrange I wrote that incorrectly. Hold on one second. Okay, we're using the equation absorbance. I started to rearrange it on you. Absorbance is equal to the concentration times epsilon, which is the slope. So if we rearrange that to get the concentration, that means that concentration C is equal to the absorbance over your slope value. All right, now we're going to take each of these cups, all right, and what do we know? Well, for cup number 1, I'm going to call it C1, we know the absorbance, 0.474. Okay, what else do we know? Well, we know the slope because we got that on the previous page from the graph. So mine is 3.42. All right, so when I divide them, I get the concentration of 0.139 grams. Okay, now you're going to do the exact same thing for cup number 2 and cup number 3. Okay, so you're going to fill in your values. You're going to get values. And then you're going to take each of them and they get plugged in to that column. Okay, so right here, we're going to plug in 0.139. Okay, my second one, I got 0.208. And my third one, 0.137. Okay, and they're all grams. Okay, now the last thing that you have to do, okay, let me switch colors again to keep things straight. Okay, we'll go to red. No, red's too dramatic. We'll go to lime green. Okay, so the next thing that I need, okay, and I will call this so that we're keeping track. I should have written this up here before. This was your 5th step to transfer it over. This was your 6th step to figure out the grams. Okay, so step number 7, okay, now involves taking those grams. Okay, so I have for cup number 1, 0.139. Okay, so from here, I'm taking that value. I'm going to divide it by the mass total. Okay, so that's my 0.6728 because remember, you're doing a mass percent. We're going to divide those and multiply by 100. Okay, so for my first one, taking it to 3 sig figs, I got 20.7%. Okay, so that goes here, 20.7%. Okay, now you're going to go through and you're going to do the exact same thing for your other ones. All right, so you're going to get a value here and you're going to get a value there. And those are your mass percents for your cobalt. Okay, now once you have that finished, okay, you are really coming down the home stretch. So let me take you back. All right, and let me stop at page 257. When I was doing this, I was actually using page 257 as a checklist. Okay, so I was going down and literally checking everything off. And literally, you are now right here. Okay, so we've done everything up through step number 7. Okay, so let me point out step number 8. Calculate the median mass percent of your 3 experimental values. Okay, so these are your experimental values. You're going to look at your values and you're going to determine what your median value is. Okay, now where does that go? This is kind of hidden. So if you go over here to data sheet number 2 continued, okay, and I have it highlighted for you in orange, it goes right here. Okay, so you're going to take whatever value is your median and you're going to insert it here. Okay, now, what do we do next? Okay, come back over here. All right, step number 9. The 3 possible molecular formulas are cobalt nitrate as an anhydrous, hydrated cobalt nitrate with 3 waters, and cobalt nitrate with 6 waters. You're going to go through and you're going to figure out your mass percent of those compounds on data sheet number 2. Okay, now, if we go back to data sheet number 2 without me doing the work for you, I want you to recall that mass percent for the cobalt is exactly like what you did earlier. Where did I put it? Right here. Okay, so if you go back and I'll highlight it for you right here, okay? That is the process you're doing. Now, the only thing different is you are going to want to multiply by 100. Okay, so for the last part, you're going to take 0.248 as an example, multiply by 100 to get it into a percent form, okay, which would be 24.8%. Now, again, that is for cobalt chloride. This happens to be cobalt nitrate, okay? So just make sure that as you're doing it, you take your mass of your cobalt divided by the total mass, including the waters, multiply by 100, and that's going to give you, when you do it for all 3, you're going to get 3% values. Okay, now, remember up here, okay, you have your median value. Okay, last part of this is you want to figure out your molecular formula. So you're going to look at your median and you're going to compare to those 3. And after you compare it, you're going to write your formula. Okay, so whatever your formula is out of these 3, so is it this one, or this one, you're going to decide that. Okay, and the instruction sheets tell us to do that. Okay, so that's step number 10. Okay, finally, step number 11 is figuring out your percent error. Okay, now for percent error, all right, it is on page 254. Okay, so if you've forgotten the percent error equation, okay, there it is. You're going to take your median, you're going to subtract the actual divided by the actual times 100 to get your percent error. Okay, so whatever you obtained for that particular one. Okay, so, again, without giving away any answers, just make sure that you refer to page 254 as you're doing that. Okay, so what else do we have to do? I showed you the graph. All right, last but not least, okay, this is a lab notebook lab. Keeping in mind that you do need to include the post-lab questions. You have to write them out and the answers to them in your lab notebook. Okay, so make sure that you do that as you're finishing up the lab. You're doing questions 1, 2A, and B. And last but not least, a discussion section. Okay, so for my students, please make sure that you provide a detailed explanation, that you don't just answer yes or no. You explain why and highlight the key things that happened throughout the lab. So my hope is that this video was helpful to you. If I was talking fast, hopefully you paused the video, and you can certainly rewind it if you need to. Please make sure that when you're finished, you do two things for me as a thank you. Thank you number one would be for me to ask you to like my YouTube channel. If you would do that, that would be great. And thank you number two would be, if you understand this work, if you would please utilize your knowledge to help someone else, because I always tell my students that if you can explain it to someone else, it shows without doubt that you understand the material. Thanks so much. See you soon.